Welcome back to Dream Cloud. I'm very excited today. We are getting to our educational portion of this presentation. So, we need to call this the Millennial Project because the components of this are growing, are getting to be multiple. So, Millennial City, Dream Cloud, the Millennial, the supply chain, also all the different factories, the freedom cities, all of that can be kind of understood within the Millennial Project. And you could compare this in America to the Manhattan Project. That's the scale in which we need to be talking about this. There was a VLSI project in Japan, I believe, in the 70s and the 80s to bring their chip manufacturing up to a level where it could compete with the West. So basically all we're doing is the opposite. Right now, the West is falling behind, and it needs to learn lessons from the East because the East used its public investment to catch up to what the West was doing, and then it surpassed it. And then the West never said, oh, we need to also make public investments in this to keep up with the East. So that's all we're not doing. Our ideology is making us refuse to make public investments in technology. And that's the only thing we have to do. So all we have to do is just change our ideology to what works instead of having an ideology of what doesn't work. So the technology ecosystem, we're going to be talking about education. We're going to be talking about the supply chain because those two things are interconnected more than you know, right? Right now, the supply chain issue in America is actually skilled labor. So, it's affecting every level of the supply chain, every link in the supply chain, because we need a specially highly skilled job or career or person to do that job, within that stage of the chain, basically. So, Millennial City, if you're unfamiliar, is a global hub for high-tech manufacturing, AI research, industrial automation. Basically, the future city that we're going to be building in America is going to be called Millennial City. And I have ideas about where this could be placed, but we need to talk about the best position. And I think I know where the best position is based on current technology trends in the country, and we'll get there. So, tech education, the Millennial Technical Institute Research Campus. This will be a free educational campus. All of this will be paid for by the technology that we create here and the licenses that we give to private companies to actually produce the cutting edge technology. All of that will feed back into the university to make it grow. So basically, everyone can come and learn here and take information. But if it's licensed, if it's trademarked, if it's patented information, then you pay the university to be able to use that information. And that's how we get our free education. We make a tech school online that mirrors the entire school in the physical, and then everybody in the world can learn every stage of the tech manufacturing, design, development process. So, as the world shifts towards AI-driven automation, semiconductor production, next-generation computing, the Millennial Technical Institute will be the nation's premier training ground. So, this will be the place where everyone comes. And if you think about it, Millennial City is the international metropolis of multicultural exchange. So this university will have people from all over the world coming, meaning that you can come here and learn technology in possibly your own language or learn it in a different language. So, high-tech skills, technical curriculum. So, real-world training. What we're going to do is we're kind of going to figure out like all of the different kind of professions in the tech industry, and then we're going to work backwards by kind of compartmentalizing everything into 3 major categories and then 3 major subcategories for each category, which would create 9 major categories, almost like a grid where everything could fit into these 3 categories. And then, obviously there's specialized courses and degrees within those categories. But this is what we need to do to create this tech ecosystem in America within the people, within the culture. This is the tech ecosystem that can be, that can work in the supply chain, which is the physical manifestation of the trade. But first, you have to actually have the people with the kind of, skills. Millennial Technical Institute curriculum is structured into 3 core categories, covering the entire tech ecosystem. So basically, that's it. 3 key areas. So hardware, right? Physical, the actual semiconductors, the fabrication, the automation, the precision metal fabrication. All of that's going to be hardware design. I mean, it has to do with design, but it also has to do with making things, and then also the materials that we use to make things is there. The second category is the software. Obviously, that would be everything that's code. But all different types, not just like software engineer is in there as like one subcategory. And that's basically everything you think you know about tech is probably just right in there with like software engineer, except for now AI. That would be a different kind of category. But these are all in software, what most people know as coding or software, computer development. And then fundamental operating system design, logic processing. Now, at the fundamental level, your computer is just talking about ones and zeros and kind of switching on and off these little logic gates, right? But your computer is running programs at the upper level. So there needs to be some kind of a language, a logic process that translates all of the things that you do on your computer into these kind of like switching on and off of these logic gates, which is basically just like electricity flowing through these transistors. So people need to know, how that works, and then, how we can make them that system more efficient in the future. So studying it now to learn how it works now, but also researching to innovate, right? And that would kind of feed back into like chip design, because like that's the computer language that informs the physical design of the chips that then get produced. So all of these things are connected, but they're specialized. And yes, they need to talk to each other, but they need to work on their own projects. So that's why they need a university to kind of collaborate while not in the actual office, built like the business, the company producing the parts. There needs to be this other place where people can come together, collaborate, and experiment on technology together. It's vital. We're already going to be creating this, potentially this new city. So let's make it a research campus. Let's make it a college town, if you will, designed for technical people who are into manufacturing, but every level of making technology, computers, but technology in general. So hardware production, semiconductor fabrication. So this is like, if you think about automation and producing things like with sparks flying and kind of like parts moving in and this thing assembling it with screwdrivers, this has nothing to do with that. This is like nanometers, everything's fragile, everything's sterile, everything moves very carefully, very precise. It's all in airlock chambers, it's all behind glass, and they're like shining light. They're magnifying light onto silicon wafers at like the smallest scale possible. And this is just sort of like, this is the stuff that we can't get. This is like the Taiwan, what is it? TSMC, semiconductor production. So this is photolithography, stereolithography, ultraviolet light. But these machines, right? We can buy them from ASML, and we can put them in the university, and people can learn on them, and people can learn how to use them to then be positioned into companies that are producing chips, and people can learn on them how to, produce better chips in the future without costing the companies any more money for research, right? And we can also build these foundries on the university for these companies to use to experiment and possibly even to make chips. I mean, there could be some kind of a overlap between where things are actually produced and where people are learning, and those could be the same place. This could be a sort of a factory as well, and students are learning how to kind of like fine tune the factory at the factory. So I'm thinking of this as like a multifunctional kind of educational production facility. So now this is regular automation, precision manufacturing, assembly line design, all that stuff. So now it's like we've created these components, we've got to put them all together, we've got to make sure that this, assembly is precise, but it's efficient, and it's, quick, and it is quality controlled, and it puts out good products that can just be packaged and tested and shipped, and that whole process of automation, which I'm even learning myself. I'd like to learn more about that. Natural resources, material research, structural engineering. So basically, what are all these things made out of? What kinds of materials are we using today? And what kinds of materials do we need to be using tomorrow? And we need people to specialize in just that kind of research and just that kind of, career. So now we're getting into software design, artificial intelligence, obviously the most important thing, machine learning, what I'm using to actually create this whole presentation right now. So that's going to be one, let's say, one square on the grid. Again, this is 3 categories and 9 subcategories. So this is number 1 in category number 2 in the software category. Cloud computing, this is the second section, the second subcategory. So this is all software. And then obviously this is software engineering. So this would be all of the various kind of, software components, or if you want to compartmentalize software into different areas, you can kind of separate AI from software engineering. And then this is the hybrid, right? This is the crossover, computational logic, operating system architecture, right? This is what actually controls the logic gates on the physical computer, which one half of the team produced to tell it the instruction set, which the other half of the school produces. So this is kind of like the people who translate or bring together, bridge software and hardware. Software hardware integration. Firmware is what it's called technically, but whatever. There's multiple different components to this. Embedded systems, obviously on robots, and then cybersecurity, right? Because people are going to be hacking these points of contact, whether it be a server or like a router or a firewall or a printer or a node, whatever it is. It's like the defense of the physical and the defense of computing is its own subject, right? So that's it. You could take basically every particular field in technology development, research, whatever, production, application, you can put it in those 9 categories. So we need to cover those 9 categories, and then obviously we need we need to sort of like appoint a specialist of cybersecurity, a specialist of AI. Do you see how those could be distinguished? And those people could be like the heads of cybersecurity and the heads of, automation. Those are going to be different people, even though they both work in tech, but there could be one distinct head in that category, right? And then those 3 heads could get together and form a kind of like, a committee of hardware, a committee of software, and a committee of the kind of middle ground firmware, integrated systems. So everyone together will obviously be working in this institute to create this educational ecosystem where they have complementary skills. They're working together. We will be teaching them real world skills because we're looking at the industry, and then we're just teaching people like what they need to know now and what they're going to need to know to, help make progress in the future. And then this will be a practical application to the technology ecosystem within the production factories that exist right now. So basically, it's like we're training you to do actual work that we need done right now. So this isn't a hypothetical, go off and get a degree and then go find yourself a job and live the American dream. This is what we need right now. These are the jobs we need trained for. We're going to train you, and you're going to work at the companies, and the companies that you work for are actually going to pay for, future education for more people. So This is a beautiful system. This is exactly what we need. So, digital online education. Because this whole university is going to be basically cloned online, anyone can have access to it and anyone can learn anywhere in the world. And you can even apply to get a scholarship to come visit the campus. So, we're going to want to create this kind of inviting environment for people who want to learn tech. If you want to, reskill, if you want to learn something, if you want to learn more about computers, if you want to, transition to a career in tech, we want this university to be as simple as possible. So if you really can't, afford to go back to school, then you can come to this university. You can work. You can go to school. You will have the ability to work to earn your education at this university, hands down. So, Freedom City number 1, Millennial City, make America great again. This is an international metropolis. It's a blueprint for the future. It will be a thriving international metropolis that merges innovation, culture, and sustainability, designed as a multicultural urban environment, right? So this educational facility fits into a larger city that we're building that's about multiculturalism, that's about inviting people from all over the world, that's about international art and culture. And yes, at the heart of this is tech, because it's a sector that's growing and it's a sector that we need to promote more and expand more, especially within the manufacturing sector in this country, in America. But we need, in order to kind of, beef up our supply chain, we need to beef up our education. So that's why we need an institute. So how are we going to pay for the institute? Well, it's going to feed back into the industry, which we're beefing up. So all these things to me are connected, and they need to be connected. And in order to run well, they need to be, they need to feed back into each other so they grow. So it's an ecosystem. Thank you for coming and, enjoying this presentation. This is DreamCloud. Again, Toxic Dreams, info at dreamcloud.club.org if you want to reach out to me. Millennial City is the future of development in America. It is. And it's a theoretical project, but it could be built. And if this is just your first video, go back and watch some of the earlier ones. We talk about Millennial City. We talk about expanding the tech sector using a American phone, and we kind of break down all the components. We also talk about Texas as a possible location and what a new waterfront kind of development city would look like. So in the future, I think that we need to kind of realize that, this is a whole city, this is a whole university, this is a whole massive, massive, massive project. And this might be the plant, and we need to find a kind of a seed to get us there. So I'm thinking in terms of actually, making something. So I've been working with AI. All of this is made with AI. I've crossed the singularity point. I can't live without AI. I need it to be able to make these things. And that's not just like a personal, I'm 200% faster and smarter with AI. So I've been working with AI to make these little computer frames, and I'm going to fill them with industry standard parts. But basically what I want to do is I want to start manufacturing these kind of all-in-one inclusive computers, right? Desktops that look really cool, but are just comprised of quality components that are already on the market. So there's all these existing computer components, and there's this whole kind of micro, industry of custom built, custom fabricated computers, right? Most of them are for gamers. Most of them are putting the most high tech, cutting edge processors and memory and storage and motherboards and graphics cards, and do you see what I'm saying? They're putting the most high tech stuff in. But this idea that you can come and you can get these components and you can put them together makes me think that maybe we can automate this process and we can produce our own shells that make sense for us stylistically as a company, right? And we can start to kind of take these lessons from Apple, which is they create a really beautiful shell. and they create like a really beautiful mouse and a really beautiful keyboard. And so what you really associate with Apple is not necessarily the software. They do have beautiful software as well, and we can talk about creating software later. Maybe a new operating system. Maybe we do something with Linux and we build a kind of like, you know, application layer, something that looks nice. We can build that on top of Linux or you know, build a clone, something kind of like a PC Apple hybrid operating system. But first, we have to have the computers, right? And look at, you know, some of the bigger American computer companies, they don't actually produce all their individual components, right? They're buying motherboards from Intel. They're buying chips from Intel. And that's like 90% of the computer. The other parts they're buying from Samsung, right? They're buying screens from them. They're probably having another company make their keyboards. They're probably having another company make their batteries. So we can do this, and we can create with a custom shell and with an automated factory and with all of these kind of like off-the-shelf components. All we have to do is train the machines to put it all together, right? Even if we fabricate, or we could work with another firm to fabricate the actual shell and then just ship us that. And what I want to do is create this American product, which is like the screen, the keyboard, the mouse, the computer, and all the components. So you can basically just get this in a box, pull it out, plug it in, it works. It's got the operating system that you want already on it, loaded, and it just comes out of the box. And each component inside, if it is made in another part of the world, what we could do is we could use this computer to invest in duplicating that part of the supply chain here in the US, and then we could replace that part in the computer. So the computer itself could become, we could watch it become, from right now, you know, maybe like a 10%, 5% made in America product to 100% made in America product. Using this computer, we could invest in all of the different companies that would make those parts in America. So it's almost like we have this device, and I want to make it clear and I want to make it open so people can see the components. So that people, as they buy this computer, they will see more and more made in America components within that computer, and they will know that this is a success when we can transition that computer from a 5% made in America to 100% made in America, and they will understand and know all the companies that make each component of that computer along the way. So that's the goal. And, you know, we could even have like someone else make the actual screen, but then we design the shell, the plastic component. You know, I want to make all the branding and the design for these computer components, right? Like very futuristic, very clean, very modern. Like this needs to look like a really, really great, modern, clean, easy to use computer, so that when people get it, they can feel good about the product and they don't feel like they're a part of something which is like something that is not cutting edge, right? So we need to make this look like, you know, a high-end, beautiful computer. And we can have different models. So we can have a basic one with like an i5 processor. We can have a more advanced one with an i7 processor with double the RAM, with double the storage. You know, we can sort of do those things with, you know, we can create two different monitors. We can do all that stuff. But essentially what we're going to be doing is helping the tech ecosystem grow. And we can use this computer to kind of teach on, you know, so we can give this computer to students and say, okay, replace that component with an American-made component. Tell us how we're going to build a new factory to make that component. How is that factory going to fit into the supply chain? So this computer itself can not just be a product that we make in America and export to the world, but it can be a you know, an object, a product that will teach people how to create supply chains in their own country. So that's the next project. And I think that that's something that we can really physically do. And I've already reached out to, evidently people make computer cases already for these custom builds. And they make these computer cases, but they wait for these kids who are gamers to buy these cases to build themselves at their house. I'm talking about buying thousands and setting them up in a production facility and making our own computers. Because what is a computer? At the end of the day, a computer is someone who makes a product that you can click buy on Amazon and have it be shipped to your house. So it's really the computer becomes the end maker in the whole assembly line process, in the whole supply chain. The computer company gets to be the person at the very end who says, "Oh, that's my computer." That's a, I don't want to say their names because of certain reasons, but let's say it's I'll just use a Samsung, right? It's a Samsung computer, right? Well, does Samsung make every single component? No. But would you call it the component? Like, you know what I mean? Like, would you call it an Intel computer? No, because Intel just makes the chips. Anyway, you get it. We're going to make a computer. We're going to make it step by step. We're going to replace all of the components with American-made components, and that's how we're going to fix our supply chain. And then, guess what? We're going to make a laptop, and then we're going to make a tablet, and then we're going to make a cell phone. So we're going to replace all of the devices that you need, the whole ecosystem of devices we're going to replace slowly. So we'll have this company will have computers, we'll have laptops, we'll have tablets, we'll have cell phones. We might even have, hearing devices, listening audio devices, headphones, things like that. So we'll get into it slowly but surely, and we'll build up that infrastructure. And here's the other thing. These factories and this university, we will be helping other American tech companies. We will not be like a competitor to like American tech companies wanting to take market share and dominate and all that stuff. We're not interested in that. We're interested in creating American tech. So we will be producers of, we will be manufacturers for other tech companies in America. Again, this is all very exciting stuff. This is how we do it. This is how we make America great again. This is how we make America build again. This is how we make America smart again. Is that what I said somewhere here? So thank you for joining me. And I really think that it's starting to kind of produce this computer would be the most fun part of this project. And here's the thing. If Millennial City and the Millennial Project, right, is this kind of, or let's just say Millennial City and the Institute, if that's the tree, if that's the kind of, the tree, then we've got to figure out what the seed is to put in the soil. And what I think it's going to be is this computer, right? Maybe the Millennial One. We create this computer, but what we do is we move to an existing city, like maybe Austin, Texas, where they have a developing tech kind of a manufacturing industry. And we say, okay, we're going to move in. We're going to create this factory. We're going to buy a factory, whatever we're going to do. We're going to start making this computer. And then when this factory gets too big, we're going to build a second factory. And we're going to start building that learning facility, that institute, that educational Millennial Technical Institute. And so basically, it's like we're going to start this company, and the intent of this company is going to be to grow beyond its own first factory into the point where it needs a second factory, and that second factory can then create the educational institution, and then we can start building Millennial City. So I think the first step is to create this seed, and the seed is Dream Cloud, and this Dream Cloud. That's funny. We've got to create this partnership between people who, like right now, I'm reaching out to companies who automate factories, right? Like there's Boston Dynamics, and they have machines that can move things around a factory. There's other companies that make things that just work in factories. So I need to figure out which robotics will fit in will work in the factory to actually make this machine, whether we're cutting it, whether we're flipping it, whether we're putting it on a CNC bed, whether we're cutting it with the CNC, moving it to another part, whether we're drilling in components, whether we're fastening down motherboards, whether we're clipping in CPUs, you know what I mean? Like whether we're testing it, like it has to be tested before it goes out. So there's this whole process of custom making a PC in your home and buying all this stuff. It's like, you may think it's no big deal because you did it a couple times, but that is such a specialized thing. And then testing it and then installing everything and then running checks. And then, if you just did all that for people, then you would be a computer maker because you would be making a computer, So yeah, right now it's going to be an assembly of components that are made on the market over the counter, we might say, over the counter computer components. But we'll be making a custom shell that is branded for our company. And we will be working with companies to make branded keyboards and branded mice and a branded screen monitor that'll be high quality. So it'll be a full computer out of the box. And like I said, slowly but surely, it will become 100% made in America. So that will be the seed that maybe we can go to Austin and we can just kind of open up a factory there and we can start talking about making this computer there. I don't know. I'm looking at San Diego too. I'm looking at Santa Ana in the kind of LA, Orange County area. So it's all about positioning this factory in the right place. Obviously, it's not the last factory we're going to build. It's just the first factory. So it doesn't need to be in the exact correct position because the next factory, we could just move there. So that's basically what we're working on. It's very exciting. Yes, you will be able to buy a computer from me in the near future when we get all this figured out. And it will be something that you will love. And you will know that by buying this computer, you are investing in American technology, the ecosystem, and everything. So thank you for joining me. Until our next video, goodbye.